Good morning.
Good morning, ma'am.
Yeah,
Good morning, ma'am.
good morning. My presentation is visible, children? Wait, the slide is empty.
Yes, ma'am.
My screen is visible, right? Yeah, okay. You can write along with me, children. Children, again, my screen is visible, right?
Yes, ma'am.
Yeah. Yeah. So you can see the identities which are used to work this one. So the numerator is a cubed plus b cubed and a cubed minus b cubed must be factorized using the relevant identities. So I've written cos cube theta plus sin cube theta, which is a cube plus b cube, as a plus b into a square minus ab plus b square. And the other numerator, cos cubed theta minus sin cube theta, using the identity a cubed minus b cubed. A minus b, a square plus ab plus b square. So cos theta minus sin theta into cos square theta plus cos theta sin theta plus sin square theta. Now you can see that the denominator is cos theta plus sin theta. And in the numerator also we have the same expression cos theta plus sin theta. So they get cancelled. And here also cos theta minus sin theta, and the numerator and denominator gets cancelled. And also cos square theta plus sin square theta is 1. So 1 minus cos theta sin theta plus here also cos square theta plus sin square theta is 1. 1 plus cos theta sin theta. And again minus cos theta sin theta plus cos theta sin theta gets cancelled. 1 plus 1 is 2. Done, children?
Yes, ma'am. No, ma'am.
Okay, finish it. Yeah. Done, children?
Yes, ma'am.
Okay.
Yes, ma'am.
All right. Yeah. So under the square root, we have tan square theta, which is like a square, cot square theta, which is like b square. And we also have 2. So if it were a square plus b square plus 2ab, then you can write that as a plus b the whole square. And also we need to get rid of the square root. So we are looking for a perfect square inside the square root. If we have a perfect square inside the square root, it's easy to get rid of the square root symbol also. So we have a squared plus b squared. Now this is 2. So you want to write that as 2ab. So for that, it should be 2 tan theta cot theta, because a is tan theta and b is cot theta. So it should be 2 tan theta cot theta. So you just write what you want it to be. You want it to be 2 into tan theta into cot theta. Just write that. And you're right also because tan theta into cot theta is 1. So you're just writing 2 into 1. What is tan theta into cot theta? It's 1 because tan theta into cot theta is 1 by tan theta. So they are reciprocal ratios. They're reciprocal ratios. So when you write 2, if you write 2 as 2 tan theta into cot theta, it's nothing but 2 into 1, which is still 2. You can also write as 2 into cos theta into secant theta, but not for this situation. 2 can also be written as 2 into cos theta into secant theta, because cos theta and secant theta, they're reciprocal ratios. Cos theta into 1 by cos theta. 1 by cos theta. So anyways, they get cancelled and it's only 2. So we know that the product of a ratio and its reciprocal is 1. So we write 2 as 2 into tan theta into cot theta, because tan theta into cot theta is anyways 1. So it is still 2. Now this is like a square plus b square plus 2ab, which is a plus b the whole square. Tan theta plus cot theta the whole square. Now you can get rid of the square root symbol. So it's like the square and the square root gets cancelled. But you're not going to show that. You're not going to show that. That's how we understand it. So you get a tan theta plus cot theta out of the square root. You get this tan theta plus cot theta out of the square root. Now tan theta is further sin theta by cos theta. Cot theta is cos theta by sin theta. Then common denominator. The numerator is sin square theta plus cos square theta. It is 1. And we write 1 by cos theta sin theta as 1 by cos theta into 1 by sin theta. So 1 by cos is secant, 1 by sin is cosecant, which is the RHS. Done writing, children?
Yes, ma'am.
Okay. All of you? It's simple to understand, children, so I'm not saying anything. Done writing, children?
No, ma'am.
Okay. Done, children?
Yes, ma'am.
All right, children, please listen to me. You can write down later. Please listen to me. Now here, you see terms that look like a square and 2ab, but they don't have their corresponding b square. So you can look at this as a square and this one as 2ab, but there is no b square term. Similarly here, this is a square, this is 2ab, but the b square term is missing. See here, this is the a square term. Cosecant theta to the power 4 is the a square term, and its 2ab term is 2 cosecant square theta. The b square term is not there. Here, secant theta to the power 4 is the a square term, and its 2ab is 2 secant square theta, but the b square term is missing. B square term is missing. So now the first thing you'll have to do is you need to arrange the terms based on the signs. Now you can see it is minus here. It's minus here, like you have minus a square. You know that in the identity, a square and b square are positive. It's a square plus b square plus 2ab, or it is a square plus b square minus 2ab. That is, in these two identities, a square and b square are always positive. So you can see here positive plus cosecant theta to the power 4. Let's write that first. Cosecant theta to the power 4. This is the a square term, and it's corresponding to ab term, minus 2 cosecant square theta. But here it is minus a square kind of. See here, I'm just rearranging the terms first. First, I'm just rearranging the terms. So here, see, you look at this as a square, but it's minus a square. We know that a square and b square should be positive. So, but it's negative here. So for that reason, what we do is we take out the minus common. We take out the minus common. So, and we write it like this. Cosecant theta to the power 4 minus 2 cosecant square theta in one bracket. Take out the minus common. and it becomes secant theta to the power 4. Minus into minus is plus. Minus into minus is plus, so 2 secant square theta. So now it's a positive a square and minus 2ab. The middle term can be minus. It's a positive a square and the middle term is minus 2ab. Now you don't have their b squares. Okay, you don't have their b squares. So see it. This can be written as cosecant theta, cosecant square theta, the whole square, minus 2 into cosecant square theta into 1. Then what do you need here to complete the square? What do you need to complete the square? What's the b square term then?
1, ma'am.
1 or 1 square minus, now working with the second bracket, secant square theta the whole square, this is a square, minus 2 into a secant square theta, into b is 1 plus b square, which is 1 square. So you can see that we, for the convenience, or in order to use the identity, we have included this term plus 1 square, that is plus 1 here and plus 1 here. We cannot do anything to change the expression. When you add something, you must subtract the same thing. Or when you multiply, you should divide by the same thing. But what have we done here? We have added 1 here. So this is plus 1. This is plus 1. And here also plus 1. But you can see the sign outside, it's minus. So it's like plus 1 and minus 1. Because this is plus 1 here in the bracket. Inside the bracket, it's plus 1. But there's a minus outside. So it's actually minus 1 then. And you can see that plus 1 and minus 1 is 0. So though we have added the b square term to both the brackets, the effect is 0 because in one bracket we have plus 1. In the other bracket also we have plus 1, but there's a minus outside that bracket. So it's like 1 and minus 1, which is 0. Which is 0. That means though visibly there are some changes, we have not changed the value of the expression. Visibly, yes. From where did this 1 square come? Visibly, there is a change. But actually, since we have 1 in one bracket and minus 1 in the other, in the bracket we have 1. But when you multiply it with the sign outside, it's minus 1. So 1 minus 1 is 0. We have not made any change with the value of the expression. Children, am I clear, or shall we repeat these steps? And let me repeat these steps. I'll write the same thing. See, now let's do it together. Yeah. So what we understand is that the a square and b square terms must be positive. It's only the middle term, plus 2ab minus 2ab. The middle term can be positive or negative, but the a square and b square terms are always positive. But we can see that the a square term here, minus secant theta to the power 4, the a square term is negative. So we start with rearranging the terms. We write the positive cosecant theta to the power 4 first, followed by its 2ab minus 2 cosecant square theta. Then we write the other a square term, which is minus secant theta to the power 4, and it's 2ab plus 2 secant square theta. So arranging the terms is the first step. Then, since a square should not be negative, we want to take out the minus common and write these two terms in a bracket. Then secant theta to the power 4 will look positive. So that's the next step. Okay, so we use brackets. cosecant theta to the power 4 minus 2 cosecant square theta in one bracket. Take it a minus secant theta to the power 4 minus into minus is plus 2 secant square theta. Now it's time to show that the terms are in the form A, this is A, cosecant square theta is A square minus cosecant square theta is A and square minus 2 into A, that is cosecant square theta, into B. See, 2 cosecant square theta, 2 cosecant square theta. So B has to be 1 because the middle term is 2 cosecant square theta. And we already have it here, 2 cosecant square theta. Then the B term should be 1. The B term has to be 1. That's why into 1. So accordingly, the B square term should be 1 square minus secant square theta the whole square. This is the A square term minus 2 into A into B. A is secant theta into B is 1. Secant square theta the whole square. A square minus 2 into secant square theta into 1. That is a 2AB term plus B square. Now this makes A minus B the whole square because minus 2AB. So A, this is A minus B the whole square. Minus the second bracket also looks like A square minus 2AB plus B square. So it will be this is A minus B the whole square. And now by the identity, cosecant square theta minus 1 is equal to cot square theta. Identity, cosecant square theta minus 1 is cot square theta. The whole square because the square is there. Minus secant square theta minus 1 is tan square theta. And the whole square. So this becomes cot theta to the power 4 minus tan theta to the power 4, which is nothing but the RHS. Is that fine, children? Please write down. Done, children?
No, ma'am.
Okay. I'll just come back in a minute. Please write. Completed?
Yes, ma'am.
All right, good. Next one. Yeah, we'll do this together. So we'll change the ratios to sine and cos. So cot theta is, yes, I want the answers from you, children. Cot theta can be written as
Cos theta by sin theta.
cos theta by sine theta. Minus cosecant theta is,
1 by sin.
okay, next. 1 plus
Sin theta by cos theta.
Sin theta by cos theta.
very good. Sine theta by cos theta.
1 by cos theta. 1 by cos theta.
Very good. Next step obviously is the, what's the next step?
Taking common. Yes. Yeah.
Common denominator. Yeah, common denominator. Yes. So what will you get in the numerator here?
Sin theta plus cos theta minus 1.
Sin theta plus cos theta minus 1.
Minus 1 into
Yeah, here
cos theta plus sin theta plus 1 by
cos theta. Yeah, cos theta plus sin theta plus 1 by cos theta. Okay. So you have to now multiply the numerators and multiply the denominators. But
cos
we'll see.
theta plus
Yeah, we'll just see if we can use any identity here to make our work easier. All right. So here in the numerator, we have sin theta plus cos theta minus 1. And here we have sin theta plus cos theta plus 1. I'm multiplying the numerators. I'm multiplying the numerators and the denominators. Multiplying the numerators, we have sin theta plus cos theta minus 1, which is like a minus b.
cos theta is common.
No, 1 second. Yeah. So sin theta plus cos theta minus 1. I've enclosed sin theta plus cos theta in a bracket, which is a minus b minus 1. And in the next term, I've written sin theta plus cos theta again in the bracket, which is a, and plus 1 outside, which is plus b. So clearly the numerators, the product of the numerators are like a minus b into a plus b. Agree, children?
Yes, ma'am.
So here we have sin theta plus cos theta, enclose that in a bracket, minus 1. Then here also we have sin theta plus cos theta in a bracket, plus 1. So it's the numerators, they look like a minus b into a plus b, which can be written as a squared minus b squared. So a squared, this is a squared minus b squared divided by sin theta cos theta. So now expand the numerator. What will it be? What is sin theta plus cos theta the whole square?
Sin square theta.
Yeah.
Plus 2 sin theta cos theta
Yeah,
Plus cos square theta.
very good. Plus cos square theta minus 1 divided by sin theta cos theta. Next, what children?
Sin theta plus sin square theta plus cos square theta is equal to 1.
1. Yeah, 1. And then
Plus
the remaining
2
terms.
sin theta cos theta minus 1 by sin theta cos theta.
Correct. Next.
Plus 1 minus 1 is 0, ma'am.
Correct.
So that 2 sin theta cos theta by sin theta cos theta. Then sin theta and sin theta cos theta will get cancelled.
Correct. So 2.
2, which is equal to RHS.
Very good, children. Thank you. Yes, write down, children. Finished, children?
Completed, ma'am.
Okay. So here, after we change the ratios to sine and cos. So the first step is obvious. We change the ratios to sine cos and then common denominator. Now after this, here you should not replace sine square a plus cos square a with 1 because it's an identity here. Sine square a plus cos square a, don't replace that with 1 because when you multiply the numerators, see, after this step, we have to multiply the numerators. You can see here I've written this one first, sine a minus cos a into, I've arranged the terms in the order to look like the identity. So sine square a plus sine a plus cos square a. The identity is a minus b into a square plus ab plus b square. So there's nothing but a cubed minus b cubed because it's a minus b. So this is nothing but a cubed minus b cubed. The numerator, when you multiply the numerators, we have a minus b into a squared plus ab plus b squared. Arrange the terms accordingly. Do not replace sine square a plus cos square a with 1 because then you will disturb the identity. So the product of the numerators is a cubed minus b cubed. A sine a, so sine cubed a is a cubed minus b is cos a. So b cubed is cos cubed a by sine square a cos square a. Multiplying the denominators, we get sine square a cos square a. Now divide each term in the numerator by the denominator. So it will be sine cubed a by sine square a cos square a minus cos cubed a by sine square a cos square a. Now, why should we do that? Is because in the RHS we have two terms. Look at the RHS. Look at the RHS. We have two terms in the RHS. So that means we have to split it at this point. So the numerator sine cubed a by the denominator sine square a cos square a minus the numerator cos cubed a divided by sine square a cos square a. So like this, now we have two terms. When you do this, now you have two terms. Now the numerator is like a cubed and denominator a squared. So that gets cancelled. So you'll have only one sine a remaining in the numerator by cos square a minus cos cubed a and cos square a cancels and you'll have only one cos a in the numerator by sine square a. Now we know this cos square a is made up of cos a and cos a. So sine a by cos a and there's one more cos a, no? So into 1 by cos a minus cos a by sine a. There's another sine a, so into 1 by sine a. Sine a by cos a is tan a, 1 by cos a is secant a. Cos a by sine a is cot a and 1 by sine a is cosecant a. Which is the RHS. Any questions, please ask me, or if you want me to repeat the whole explanation, we can do that. I can also work it again for you if it's not clear. Understand, children?
Yes, ma'am.
Understood, ma'am.
Okay. Okay. So you see that the RHS is only in terms of cot. Cosecant is in the left hand side, we have cot and cosecant. But on the right hand side, we have only cot. That means we have to replace cosecant square A and cosecant square B with cot square A and cot square B. That we get, so we look at the RHS. We look at the RHS, we see that cosecant A or cosecant B is absent there. So that means in the LHS, you'll have to replace cosecant square A and cosecant square B with cot square A and cot square B. So cot square A into cosecant square B. Cosecant square theta minus cot square theta is 1. So cosecant square theta is 1 plus cot square theta. Cosecant square theta is equal to 1 plus cot square theta. So cosecant square B will be 1 plus cot square B minus cot square B into cosecant square A will be 1 plus cot square A. Cosecant square A minus cot square A is 1. So cosecant square A is equal to 1 plus cot square A. So now we don't have cosecant square A and B. The entire expression is in terms of cot A and cot B. Now multiply, open the bracket, cot square A plus cot square A, cot square B minus cot square B minus cot square A, cot square B. Correct? So you can see plus cot square A, cot square B minus cot square A, cot square B gets cancelled. So we are left with cot square A minus cot square B, which is the RHS. Done writing, children?
Yes, ma'am.
Okay. Now we need to get rid of the square root. We need to get rid of the square root. So we are trying to, make the terms under the square root a perfect square. We're trying to make the terms under the square root perfect squares. So the denominator is 1 minus sine theta. We'll multiply the numerator and denominator with 1 plus sine theta. The opposite sign, 1 plus sine theta by 1 plus sine theta. The same thing in the other one. 1 minus sine theta divided by 1 plus sine theta. We'll multiply the numerator and denominator with the opposite sign. The denominator is 1 plus sine theta. So we'll multiply and divide with 1 minus sine theta. So you get 1 plus sine theta into 1 plus sine theta is 1 plus sine theta the whole square. 1 plus sine theta the whole square divided by 1 minus sine theta into 1 plus sine theta. A plus b into a minus b is a square minus b square. Again here, 1 minus sine theta into 1 minus sine theta is 1 minus sine theta the whole square divided by a plus b into a minus b, which is a square minus b square, 1 minus sine square theta. Now the numerator you can see is a perfect square. In both, under both the square roots, the numerator is a perfect square. The denominator is not. So we'll just do one more step before we bring them out of the square root. We'll write the numerator as it is. We'll not square it. It's a perfect square, so don't disturb it. In order to get rid of the square root symbol, you wanted the terms under the square root to be a perfect square. So 1 plus sine theta the whole square is a perfect square. So don't expand it. Don't expand. Now what is 1 minus cos square theta? Sorry, what is 1 minus sine square theta, children?
Cos square theta.
Cos square theta. Now this is also a perfect square. This one is also now a perfect square. Don't disturb the numerator. It's a perfect square. The denominator is 1 minus sine square theta is cos square theta. Now we have perfect squares under the square root. Get them out. The numerator is 1 plus sine theta the whole square. So it will come out as 1 plus sine theta divided by cos square theta. That is cos theta into cos theta. So out of the square root, 1 plus cos, 1 cos theta will come out. Then 1 minus sine theta divided by cos square theta. No? So 1 cos theta comes out. Now common denominator. Common denominator. So you see plus sine theta minus sine theta gets cancelled. So we have 2 by cos theta. We have 2 by cos theta, which is nothing but 2 into 1 by cos theta. 2 into 1 by cos theta, which is 2 secant theta, which is the RHS. Please come back, children. Please write. Finish writing, children?
Yes, ma'am.
So here the thing is we need to get rid of the square root symbol. So we have to make the expressions under the square root a perfect square. Then we can get rid of the square root symbol. So we start like this, under the square root, the denominator in the first part is 1 minus sine theta. So we multiply and divide by 1 plus sine theta under the first square root. Then under the second one, the denominator is 1 plus sine theta. So we multiply and divide by 1 minus sine theta with the opposite sign. So that way the numerators become a perfect square because 1 plus sine theta into 1 plus sine theta is 1 plus sine theta the whole square. And in the other one, 1 minus sine theta into 1 minus sine theta is 1 minus sine theta the whole square. So like this, the numerators are now perfect squares. Don't expand them. Don't disturb the perfect squares. Have them as they are. Now the denominators are not perfect squares. The denominators, we multiplied them using the identity a minus b into a plus b is equal to a squared minus b squared. So we have a squared minus b squared in the denominators, which is not a perfect square. So again, we use the identity. 1 minus sine square theta is cos square theta. So now cos square theta is a perfect square. Again, 1 minus sine square theta is cos square theta, which is a perfect square in both the cases. So now under the square root, both the numerator and denominator are perfect squares. So you can get rid of the square root symbol now. So 1 plus sine theta the whole square. That means there are two. It's 1 plus sine theta into 1 plus sine theta under the square root. So one of it comes out. Again, cos square theta means cos theta into cos theta. So 1 cos theta comes out of the square root. Same thing for the other one. Then common denominator, 2 by cos theta, which is nothing but 2 into 1 by cos theta, which is 2 secant theta. So now when you look at this, you must realize that the terms can be expressed in the form a cubed plus b cubed minus 3ab into a minus b. 1 minute, I've gone wrong with the sign. It's not, it's plus here. Yeah. So when you look at this, you must realize that this expression can be written as a cubed plus b cubed plus 3ab into a plus b. We have a cubed plus b cubed plus 3ab into a plus b is equal to a plus b the whole cubed. And we also have a cubed minus b cubed minus 3ab into a minus b is equal to a minus b the whole cubed. So it's the first identity here because you can see all the terms are positive. So the first identity. So sine theta to the power 6 should be written as a the whole cubed. A the whole cube. A the whole cube plus cos theta to the power 6 should be written as b the whole cubed. Then there should be 3ab term and the a plus b term. If you have all this, then you can write it as a plus b the whole cube. So now what in the bracket, children? What should I write in the bracket?
Sine square theta.
Sine square theta. Sine square theta. And the second bracket?
Cos square theta.
Cos square theta. So what is a then?
Sine square theta.
And b?
Cos square theta.
Yeah. Now, I hope we understood why you should not put a square outside. We are making use of this identity. A cubed plus b cubed plus 3ab into a plus b is equal to a plus b the whole cube. Now, how to decide that we have to use this? Because we have terms that look like them. See, we can write this as a cube. We can write this as b cube. You can see the 3 here. 3ab. If it's 2, if you have 2, then it is mostly a squared plus b squared plus 2ab. If you have 3, this one happens only in this identity, a cube plus b cube plus 3ab into a plus b. So since you have a term that can be written as a the whole cube. You have another term that can be written as b the whole cube. And then you have something that looks like 3ab. So we are trying to write this expression in the form a the whole cubed plus b the whole cubed plus 3 into a into b, 3 into a into b, a into b into a plus b, a plus b. We're trying to get all these terms. So a is sine square theta because 2 3s are 6 and b is cos square theta. 2 3s are 6. So now we identified a and b. Now let's fill the others. So 3ab. 3ab is 3 sines because we know a is sine square theta and b is cos square theta. So 3ab, 3a, this is a and this is b. Into a plus b, you have to write that a. This is a plus b. Now just check if you have made any change to the given expression. This one is there already. This one is also there. 3 sine square theta cos square theta is also there. This one is also there. This one is not there in the given expression, but we have written by ourselves. But it's still fine because sine square theta plus cos square theta is 1. So you've just written into 1. So it doesn't make a difference. The remaining terms are already there in the expression. See, this one was already there. This one was there. This one was there. And this one also was there. So we have written this one by ourselves. This is not there in the expression, but we have written this. But it's fine because sine square theta plus cos square theta is 1. So you've written into 1. So you're not changing the value of the expression. See, if you add 1, you have to subtract 1. If you add 2, you'll have to subtract 2. Here you're just multiplying by 1, which means you're not changing the value of anything. Into 1 is the same thing. So now this looks like a cube plus b cube plus 3ab into a plus b, which is nothing but a plus b the whole cube. What is a, children?
Sine square theta.
Plus b. B?
Cos square theta.
So this is a plus b, the whole cubed. The identity says this one makes a plus b the whole cubed. A sine square theta, b is cos square theta. So a plus b the whole cubed. So there's nothing but 1 cube, which is 1, which is the RHS. Yeah, take down, children. Done, children? Finish writing?
Complete.
Yeah. Okay. So just to make it look simple, no, I'll work it in parts. I'll not do, the whole thing once. Let's just do it in parts. Let's take up the first one. 2 into sine theta to the power 6 plus cos theta to the power 6. Okay. So now this should be written as 2 into, see, when it is 6, we know that 2 3s are a 6 or 3 2s are also 6. But you must choose to put the 3 outside because you want sine square theta inside. Because the identity sine square theta plus cos square theta is 1. So you don't want sine cubed theta. You don't want sine cubed theta. You want sine square theta. So always write sine square theta in the bracket and put the 3 outside. Don't write sine cubed theta and put the square outside. Don't do that. Write sine square theta in the bracket and put the 3 outside. 2 3s are 6. Because you want sine theta to the power 2, not 3. Similarly, you want cos square theta. So put the power 3 outside. So this is the first step. Now this is like a cubed plus b cubed. This is like a cubed plus b cubed. So a cubed plus b cubed is a plus b into a square minus ab plus b square. You can use this one, or you can also use a cubed plus b cubed is equal to a plus b the whole cube minus 3ab into a plus b. Now this one will help you better than this. You can get it. You can use this also, but this will help you better because you have a plus b here and a plus b here. You have a plus b here and a plus b here. What is a plus b? Sine square theta plus cos square theta. So sine square theta plus cos square theta is 1. Sine square theta plus cos square theta is 1. So this one will help you better. We'll see how we get this identity. See, you know the original. A cubed plus b cubed plus 3ab into a plus b is equal to a plus b the whole cube. You know this. This is the identity. A cube plus b cube plus 3ab into a plus b is equal to a plus b the whole cube. Now when you transpose this term, when you transpose this, you get a cubed plus b cubed is equal to a plus b the whole cubed. And this term is preceded with the plus sign. So on the other side, it will become minus 3ab into a plus b. This is one term. This plus sign will become minus on the other side. This plus will become minus on the other side. We use this one. So a cube plus b cube is a plus b the whole cubed. This is a plus b the whole cube minus 3ab into a plus b. I need to clear the identities at one place. I'll write it again. I'll write this one again. Maybe in the end, we'll write the identities in the end. So a cube plus b cube is a plus b the whole cube minus 3ab minus 3 into a into b minus 3ab into a plus b into a sine square theta plus b cos square theta. See here we know a sine square theta, b cos square theta. So a plus b the whole cube, a cube plus b cube is equal to a plus b the whole cube minus 3ab into a plus b. So this is 2 into sine square theta plus cos square theta is 1. 1 cubed is 1 minus 3 sine square theta cos square theta into 1. Because again sine square theta plus cos square theta is 1. So into 1. So you can just ignore it. So this gives you 2 minus 6 sine square theta cos square theta. 2 minus 6 sine square theta cos square theta. Have this result. Have this result. Now we'll work the next one. So the identity we used here is identity used is this is the original one. A cubed plus b cubed plus 3ab into a plus b is equal to a plus b the whole cube. Now on transposing this, we get a cube plus b cube is equal to a plus b the whole cube minus 3ab into a plus b. This is what we have used here. And we choose to use this identity because we have a plus b, and a plus b will make sine square theta plus cos square theta, which is 1. Now the second part is 3 into sine theta to the power 4 plus cos theta to the power 4. So let's work that here. 3 into, don't take the sign. That minus sign we can deal with later. This minus we can do later. So 3 into sine theta to the power 4 plus cos theta to the power 4. That's the second part. Now this one is like a square plus b square. A square plus b square. This one is like a square plus b square. Now what is a square plus b square plus 2ab? It is a plus b the whole square. So a square plus b square is equal to a plus b the whole square minus 2ab. Transposing. So we understand that this is of the form a square plus b square. Why? Because it can be written as sine square theta the whole square plus cos square theta the whole square. Okay, so this is 3. And what is a square plus b square? It is a plus b the whole square minus 2ab. It's a plus b the whole square. A This is A plus B, the whole square, minus 2AB. 2AB is 2 sine square theta, cos square theta. A square plus B square is A plus B the whole square minus 2AB, where A is sine square theta and B is cos square theta. So now 3 into, this is 1, so 1 square is 1 minus 2 sine square theta, cos square theta. So now multiplying 3 minus 6 sine square theta, cos square theta. Now the LHS becomes, LHS is equal to, what's the answer for the first part of the LHS? For the first part of the LHS, it is 2 minus 2, okay, let me write the LHS. So it is 2 into this is the LHS. This is the LHS. We simplified the first part. Okay, so what's the answer for the first part we got? Here, 2 minus 6 sine square theta, cos square theta. So we'll write that here. 2 minus 6 sine square theta, cos square theta. This is the answer for the first one. Minus, this minus is so dangerous. Write that minus. What's the answer we got for this one? 3 into sine theta to the power 4 plus cos theta to the power 4. We got 3 minus 6 sine square theta, cos square theta. We got 3 minus 6 sine square theta, cos square theta. And then plus 1. Now open the bracket. So it will be 2 minus 6 sine square theta, cos square theta, minus 3 plus 6 sine square theta, cos square theta, plus 1. So this and this gets cancelled. 2 minus 3 is minus 1, and minus 1 plus 1 is 0, which is the RHS. Yeah, right on, children. Done writing the slide, children?
Completed, ma'am.
Okay. Done, children? Shall we go to the next one? Shall we go to the next one, children? Done writing?
1 minute, ma'am.
Okay. Okay.
Completed, ma'am.
Completed, ma'am.
Yeah, children. I was away, so I couldn't acknowledge. Yeah. Next one. Okay. So we have seen a similar situation earlier when the left hand side is made up of only sine theta, cos theta, and 1. Then we have to start off by dividing the numerator and denominator either by sine theta or by cos theta. The left hand side is entirely made up of sine theta, cos theta, and 1. If the left hand side looks like this, then you'll have to start off by dividing the numerator and the denominator by sine theta or cos theta, whichever is appropriate for the situation. So what we do is we need to take that help from the RHS. If the RHS is made, the RHS can be made up of secant and tan or cosecant and cot. The right hand side can be made up of secant and tan or cosecant and cot. Now we don't have any of them in the right hand side. It's 1 plus sine theta by cos theta on the right hand side. So what we do in the rough column, we just work the right hand side. We just work the right hand side in the rough column. So it's 1 by cos theta plus sine theta by cos theta. 1 by cos theta secant theta plus tan theta. So the RHS is actually secant theta plus tan theta. You can see that. The RHS is actually secant theta plus tan theta. So now, by what should you divide, children, to get secant and tan? We need to get secant theta and tan theta. So will you divide by sine theta or by cos theta?
Cos theta, ma'am.
Yeah, because we'll have to get secant and tan. So we have to divide by cos theta. Sine theta plus 1 minus cos theta divided by cos theta. Now sine theta by cos theta will be 1. 1 by cos theta is secant theta minus cos by cos is 1 divided by sine theta minus 1 plus cos theta divided by cos theta. So we divide both the numerator and denominator by cos theta. So sine theta by cos theta. Sine theta by cos theta plus 1 by cos theta minus cos theta by cos theta divided by sine theta by cos theta minus 1 by cos theta plus cos theta by cos theta. So that gives us tan theta plus secant theta minus 1 divided by tan theta minus secant theta plus 1. Now, again, this also we have seen earlier. When we have a situation like this, we don't disturb the denominator. When the numerator and see now here, this one is the numerator and denominator. They are made up of tan theta, secant theta, and 1. It can also be cosecant theta, cot theta, and 1. The situation can be tan theta, secant theta, and 1, or cosecant theta, cot theta, and 1. So when it looks like this, what you have to do is you should not disturb the denominator. Do not disturb the denominator. Write the denominator as it is. 1 minute. Let me write dr. The denominator as it is. In the numerator, in place of 1, in the numerator, in place of 1, write tan square secant square theta minus tan square theta. Because secant square theta minus tan square theta is 1. So replace 1 with secant square theta minus tan square theta. The denominator undisturbed. 1 in the numerator should be written as secant square theta minus tan square theta because that's 1. So now this is equal to, I'll just rearrange the terms. I'll write secant theta first. So secant theta plus tan theta in one bracket minus secant square theta minus tan square theta is a plus b into a minus b. So a secant theta plus tan theta into secant theta minus tan theta. Just write this more neatly. So minus secant theta plus tan theta into secant theta minus tan theta divided by the denominator as it is. Now take out common. Now secant theta plus tan theta is A. Secant theta plus tan theta is A. Secant theta minus tan theta is B. So we have something like A minus AB. So you'll have to take out A common and you'll get 1 minus B. So tell me, children, what's common? What should be taken out common, children?
Secant theta plus tan theta.
Correct. Secant theta plus tan theta is common. And what in the bracket? What in the bracket, children?
1, ma'am.
1.
Minus 1.
1 minus 1, no?
1 minus secant theta minus tan theta.
1 minus secant theta minus tan theta in a bracket. So upon taking secant theta plus tan theta common, you get 1. I've written the example above. A minus AB will be A common bracket 1 minus B. Similarly here, secant theta plus tan theta is common. That's A. That's common. So in the bracket, you will get 1 minus B. What is 1? 1 is 1. Minus what is B? Secant theta minus tan theta is B. There's a minus, children, so we'll have to write it in the bracket. Now this is secant theta plus tan theta. Secant theta plus tan theta. And here 1 minus secant theta plus tan theta. 1 minus secant theta plus tan theta, because when you open the bracket, multiply the terms with the minus sign. So minus secant theta plus tan theta divided by what's the denominator? Denominator is tan theta minus secant theta plus 1. This is the denominator. So you can see a tan theta minus secant theta plus 1 plus 1. This expression gets cancelled as a whole. Now we are left with secant theta plus tan theta. We are left with secant theta plus tan theta. So secant theta is 1 by cos theta. Tan theta sin theta by cos theta. Cos theta common denominator. 1 plus sin theta, which is also the RHS. Write down, children. Done writing, children?
Yes, ma'am.
Okay. All of you? Anybody still writing?
Completed.
Okay. Yeah, you must have all completed. Okay, class, use the emoji, raise your hand. Raghavi, Dilipan, Florentina, Raja, Sri Ranjan, Danya, Rakshita. Pushmi, you're there? Okay. All right, children. So that's it for today's session. Thank you so much. You leave the call. Have a nice day.
Thank you, ma'am.
Thank you.
Thank you, children.